Hi there. For this video, I'll be sharing a trick that you can use to quickly determine if two equations are parallel, perpendicular, or not. So here's the trick. So given ax plus by equals c, or an equation of line in its standard form, a line parallel to this is of the form ax plus by equals d, wherein d is not equal to c. Moreover, a line perpendicular to this is of the form bx minus ay equals e, wherein e can take any value, so it can be c, d, or whatever that is. So observe here that a line parallel to this has similar form here in the left side of the equation, but with a different value on the right side. For the perpendicular one, take note that given this one, what happens is that the coefficients of x and y switches with the sign changing out here. So those are the key points that you need to remember in applying this trick. So I hope that you took note of this, as on the next slide we'll be showing a proof on how we arrived with this. So given this one, given ax plus by equals c, what we first do is we write this one in its slope-intercept form. So if you don't know what or how to write an equation of a line into its slope-intercept form, I'll probably link somewhere around this video my video on slope-intercept forms. So to do that, take note that the slope-intercept form is of the form y equals mx plus b, wherein m represents the slope and b represents the y-intercept. Okay, so let's start solving this one. So to make this in its slope-intercept form, we start by subtracting ax both sides, since our goal is to isolate y on one side of the equation. This will give us by equals negative ax plus c. Then we divide b both sides to obtain y equals negative a over b times x plus c over b. So we take note of this equation out here. Now previously, from the previous slide, recall that a line parallel to this is ax plus by equals d, wherein d is not equal to c. So this is what we claim to be parallel to the given one. To show that this is true, we also convert this to its slope-intercept form. So similarly, we start by subtracting ax both sides. This would give us by equals negative ax plus d. Then we divide b both sides And this would give us y equals negative a over b x plus d over b. And let's try to compare this to our given equation. Take note that the slopes out here are equal. Moreover, the y-intercept out here is not equal. And if we recall, the important remark or an important property in parallel lines is that their slopes are equal while their y-intercept are not equal. So this is indeed parallel to the given. Just to put some emphasis, this is not equal to this since we know that D is not equal to C. So again, this one is indeed parallel. Let's move on to the perpendicular one. From the previous slide, we claim that bx minus ay equals e, wherein e can take any value, is perpendicular to this given line. So similar to the parallel case, we show that this is true by converting this into its slope-intercept form. So we'll do just that. So we have here, subtract bx both sides since, again, our goal is to isolate y on one side of the equation. This would give us negative ay equals negative bx plus e. After this, what we do is we divide negative a both sides to obtain y equals b over a times x plus negative e over a. And now let's compare this to our given equation in slope-intercept form. Take note that in perpendicular lines, the important thing is their slopes. So let's focus our attention on these two out here. Take note that in perpendicular lines, the slopes or the relationship of the slopes is negative reciprocal. And this is clearly true in this case since the negative reciprocal of negative a over b is b over a. Or, to show that these two are indeed perpendicular, take note that in perpendicular lines, the product of their slopes must be equal to negative 1. And if we do that out here, we'll have negative a over b times b over a. So this one cancels, and we'll be left with negative 1. So this is indeed true. Therefore, we can conclude that the given form bx minus ay equals e is indeed perpendicular to this one. So just to emphasize, what we need to remember is, given this one, a line parallel to it is of this form, wherein d is not equal to c, and a line perpendicular to it is given by this form. So these are the things that we need to remember in quickly solving or determining if a line is parallel, perpendicular, or not. Now let's try to showcase this through an example. So given 3x plus 2y equals 5, we determine if the given items are parallel, perpendicular, or neither of the two. As a guide, let's have this. So this will serve as our reference in answering these items. So starting with letter A, this one, we observe that the coefficients of x and y matches the coefficients of the given. That is, the left side, that is the left side of the equation out here matches the left side of the equation of A. Moreover, the right side of the equation, 5 and 3, are not equal. So if we try to observe it out here, is it parallel, perpendicular, or neither? Clearly, it is parallel since the left side of the equation ax plus by is the same. But in here, it is different. So we can conclude that this one, this letter A, is parallel to the given line or the given equation of the line. As a verification, if we graph this one, clearly these two lines are indeed parallel since they never intersect. They never intersect one another. Let's move on to letter B. In here, observe that the coefficient of A, or rather x, in the given one move to the coefficient of y in B. Similarly, 2 out here, the coefficient of y in the given moves to the coefficient of x in letter B, with the sign changing out here. So which among these matches what we have? Is it parallel, perpendicular, or neither? Clearly, it is perpendicular since B out here moves here and A out here moves here with a sign change. So the coefficient switched with a sign change. Therefore, this letter B is indeed perpendicular. And indeed, if we check its graph, we can clearly see that these two lines are perpendicular. If we try to observe, this one out here is right angle. Therefore, these two lines are indeed perpendicular and we got the correct answer. Let's have this last item. In here we have 3x minus 2y equals 5. Observe here that the coefficients for x and y remains the same, but there isn't any sign change, or rather there is a sign change. So the coefficients remain the same, but there is a sign change. So what does this mean? Is it parallel, perpendicular, or neither? The answer is it's neither of the two, since it can't be parallel. Since in parallel, the coefficients remain the same with no sign change. For perpendicular, there is a sign change, but the coefficients must switch places. Therefore, letter C, the answer for letter C is neither of the two. And indeed, if we check its graph, clearly these two lines out here are not parallel since they intersect. Moreover, it is also not perpendicular since clearly this out here is not 90 degrees. So these are our answers for this example. Again, the first one is parallel, the second one is perpendicular, and the last one is neither. So as you can see, without even converting it to the slope-intercept form, just by simply looking at the standard form, we can quickly determine if a line is parallel, perpendicular, or not. To end this, here's an exercise that you can work on. So given negative x plus 5y equals 0, similar to our example, we determine if A, B, and C are either parallel, perpendicular, or neither of the two. So the steps are similar to what we had in the example, but there is just some slight trick or manipulation that you'll be needing in order to answer these items. So yeah, that's it. So feel free to comment down below your solutions and answers to these items. And if you need help or you're kind of stuck, don't hesitate to comment down in here and I'll try my best to answer your questions. So that's it. I hope you learned a lot from this one. And that is all for this video.